Assalamualaikum and hi everyone. In this video, we are going to learn about 3.2 empirical and molecular formula. At the end of this lesson, you should be able to define the terms empirical and molecular formula, determine empirical and molecular formula from mass composition and combustion data. Empirical formula is a chemical formula that shows the simplest ratio of all elements in a molecule, while molecular formula is a chemical formula that shows the actual number of atoms of each element in a molecule. The relationship is molecular formula is equals to N times empirical formula. Remember that N is not number of mole. N is equals to relative molecular mass of molecular formula divided with relative molecular mass of empirical formula. There are three types of data given in order to calculate empirical formula from. The first one is masses of constituents. The second one is percentage composition by mass. And the third one is combustion data. This one is new for you. First of all, we take a look on how to determine the empirical formula from the masses of constituent. Have a look at this example number 1. A compound is found to contain 0.233 gram magnesium, 0.307 gram sulfur, and 0.460 gram oxygen. What is the empirical formula of this compound? This is the relative atomic mass of magnesium, sulfur, and oxygen. You will need it in calculating the number of mole of each elements given. First of all, construct a table consisting of elements, mass with the unit of gram, number of mole with the unit of mole, and the formula to calculate mole is mass divided with molar mass, and the last one is ratio, or the simplest ratio. Next, list down all the elements present. And then, write down the mass of each element given from the questions. Next, by using this formula, you can calculate the number of mole of magnesium, sulfur, and oxygen by dividing the mass given from the question with the molar mass from the list of relative atomic mass. Based on these values, sulfur has the smallest number of mole. Therefore, it will be the denominator for each of the elements present to calculate the ratio, or the smallest ratio. Based on this smallest ratio calculated, we can simply conclude that the empirical formula for this compound is MgSO3. Now let's move on to example number 2. A sample of hydrated compound contain 4 gram of calcium, 7.1 gram of chlorine and 7.2 gram of water, where hydrated means that the 7.2 gram of water will be calculated together. First of all, you have to construct the elements, mass, mole and ratio table, similar as previous example. Since this is a hydrated compound, the 7.2 gram of water will be placed in the same column to calculate the number of mole of water rather than separated H and O as elements. Fill in the table with the correct mass from the question and then proceed with calculating the number of mole by dividing mass with the molar mass, and then calculate the ratio by finding the smallest number of mole as the denominator. And finally, do not forget to conclude your empirical formula next to the table, where for this question the empirical formula is CaCl2 dot 4H2O This shows that it is a hydrated compound where H2O stays together. Let's proceed to the next type of data, which is percentage composition by mass. As you can see from this example, the mass given is not in gram. Rather, it is presented to you as percentage by mass. Remember that hydrocarbon is a compound which contains only hydrogen and carbon atoms. The percentage composition by mass for this question is 85.7% carbon and 14.3% hydrogen. Determine its empirical formula. Before we proceed, you need to assume that the mass of the compound in this question is 100 gram. Therefore, it is safe to say that carbon has the mass of 85.7 gram and hydrogen is 14.3 gram. Next, you can proceed to answer the question by constructing the table consisting of element, mass, mole, and ratio, and then fill all the data from the question accordingly. calculate the number of mole by dividing mass with molar mass, and then compare which one has the smallest number of mole so that we can find out which one will be the denominator to calculate the simplest ratio. And as usual, summarize your answer by writing them down next to the table. For this question, the empirical formula for the compound is CH2. Now let's move on to example number 4. Ascorbic acid or vitamin C contains of carbon, hydrogen and oxygen. It is composed of 40.92% carbon and 54.50% oxygen, while the remaining is hydrogen by mass. Since the percentage by mass of hydrogen is not present to you in the question, you need to calculate it first by deducting 100% with the percentage of carbon and oxygen. As usual, since the data given in this question is percentage by mass, you need to assume that the mass of the compound is 100 gram, so that we can assume that each of the percentage of the elements is equal to its mass. As usual, construct the table containing elements, mass, mole and ratio, and then filling in all the data from the question, calculate the number of mole, and finally calculate the ratio by determining the smallest number of mole as the denominator. As you can see here, the ratio of hydrogen is not a whole number. Therefore, you have to multiply the value with a certain number so that it can give a whole number. In this case, I multiply the values with 3 so that all the ratio will give a whole number. Last but not the least, summarize your answer next to the table. The empirical formula for ascorbic acid or vitamin C is C3O3H4. Let's move on to the last type of data to calculate empirical formula from, which is combustion data. When a compound is combusted in excess oxygen, carbon dioxide and water are produced. From this data, we can calculate the mass of carbon from carbon dioxide and mass of hydrogen from water. Be reminded that the mass of oxygen cannot be obtained from carbon dioxide and water because the oxygen might come from the surrounding. Let's have a look at example number 5. You have to calculate the mass of carbon and the mass of hydrogen by using mole concept or formula from the mass of carbon dioxide and water. I'll show you the first method first, which is by using mole concept. Let's find the mass of carbon from carbon dioxide. The mass of 1 mole of carbon dioxide is equals to 44 grams. How many mole of carbon dioxide in 2.52 grams of carbon dioxide as given in the question? We make a cross multiplication to find the value of x, which is 0.05727 mole of carbon dioxide. One mole of carbon dioxide contains 1 mole of carbon atom. This is from the molecular formula of carbon dioxide. Therefore, 0.05727 mole of carbon dioxide contains 0.05727 mole of carbon atom, since the mole ratio of carbon dioxide and carbon atom is 1:1. Next, 1 mole of carbon has the mass of 12 grams. This is from the relative atomic mass of carbon. Therefore, 0.05727 mole of carbon has the mass of, again, we do a cross multiplication to find out the value of y. Now we can finally find out the mass of carbon atom from carbon dioxide, and the value is 0.6872 gram of carbon. We need to do the same thing with water to find out the mass of hydrogen. By using mole concept, 1 mole of water has the mass of 18 grams. From the question, 0.44 gram of water is given. Therefore, how many mole of water contains in 0.443 gram of water? Do a cross multiplication to find out the value. One mole of H2O contains 2 mole of H atom. This is based on the molecular formula of water, which is H2O. There are 2 mole of hydrogen atoms in 1 mole of water. Therefore, 0.02461 mole of water contains how many mole of hydrogen atom? Do a cross multiplication to find this value. Finally, 1 mole of hydrogen atom has the mass of 1 gram. Therefore, 0.04922 mole of hydrogen atoms will have 0.04922 gram. Now we have both the mass of carbon atom and hydrogen atom. Now I would like to show you the second method by using formula. To find out the mass of carbon, relative atomic mass of carbon is divided with relative molecular mass of carbon dioxide times the mass of carbon dioxide given in the question. By substituting the value, the mass of carbon is equals to 12 divided with 44 times the mass of carbon from the question, which is 2.52 grams. And finally we get the answer, which is 0.6872 grams. This value is similar to the value that we calculated by using the mole concept as shown here. Now let's find the mass of hydrogen from water. The formula is 2 times the relative atomic mass of hydrogen divided with relative molecular mass of water. The 2 here is because there are 2 moles of hydrogen in 1 mole of water. Times it with the mass of water from the question. By substituting the value, 2 divided with 18 times with the mass of water given in the question, which is 0.443 grams, which result to the value of 0.04922 grams. This value is similar to the value found from the mole concept method. The total mass of carbon and hydrogen calculated here is less than 1 gram of the mass of sample A. Therefore, the remaining mass must come from another element that present in the compound, which is oxygen. Therefore, the mass of oxygen can be found by subtracting the mass of compound A with the mass of carbon and the mass of hydrogen. As usual, when you already have all the masses of each element present in the compound, we can proceed to construct the table containing elements, mass, mole and ratio, and proceed to calculate the number of mole and ratio. As you can see here, the ratio for carbon is not a whole number. Therefore, the value is times or multiplied with 2. Don't forget to summarize your empirical formula next to the table. For this question, the empirical formula for the compound is C7H6O2. Remember that never round off values of ratio unless it is smaller than plus minus 0.2. How to find molecular formula? After you have determined the empirical formula, use the following formula to find the ratio of molecular to empirical. N is equal to relative molecular mass of molecular formula divided by relative molecular formula of empirical formula. And then the value of N will give you the idea on how much the empirical formula is multiplied to obtain molecular formula. Let's have a look at this last example. This question is from example 4. From example 4, we found out that the empirical formula for ascorbic acid is C3H4O3. From the question, the molar mass of ascorbic acid is 176 gram per mole. This value is similar to the relative molecular mass for molecular formula. Therefore, we can use this value to calculate the value of N. While for the value of RMM for empirical formula is calculated from the empirical formula of ascorbic acid, which is C3H4O3. Since the value of N is 2, therefore the molecular formula of ascorbic acid is C6H8O6. Quote of the day: when the going gets tough, the tough get empirical, by John Carroll. Before we end the lesson today, let's try some exercises. You may pause the video and do the questions yourself first before looking at the answer. All the best! Now let's try exercise number 2. You may pause the video before looking at the answers. For the final exercise, let's do this. I hope you enjoyed the video and have tried all the exercises given. Thank you.